Assalamualaikum and hi class, welcome back to my video. In this one, we're going to discuss about hypothesis testing for population variance, and for this parameter, we're going to use the chi-square test to conduct the hypothesis testing, which means that your step 2 will no longer be a z-test or a t-test, but it will only be a chi-square test. So the formula for your test statistic for this parameter, which is population variance, is this one, okay? N minus 1 multiplied by the sample variance divided by the hypothesized variance. So the sigma square not in this formula here is the hypothesized variance, which is the hypothesized value that will appear in your hypothesis statement. Alright, so this hypothesis testing is for any claim or hypothesis that is concerning about a population variance. And of course, there are three possible types of tail test, which is two-tail test, right-tail test, and left-tail test. And then since your step 2 will be a chi-square test, therefore in your step 3, to establish the rejection region and critical value, it will also comes from the chi-square distribution table, which means that your critical value here is a chi-square critical value. And the critical value that we're gonna establish for this type of hypothesis testing is a little bit different compared to the one that we did before, which is the Z and the T critical value. In this case, class, if you have a two-tailed test, hypothesis testing for population variance, okay, so yeah, the rejection region is the same, one on the left-hand side and one on the right-hand side, but the critical value, okay, previously in the Z and T critical value, if left-hand side, it will be negative Z, correct or not? Left-hand side, it should be negative T. But for population variance, okay, for this hypothesis testing, both left and right hand side should remain positive. So this is a bit different lah from the Z and the T distribution. For chi-square distribution, both right hand side for the two-tail test should stay positive, because this is about population variance. If you think about the logic of it, variance should never be zero. Variance will never be a negative value. So for that same reason, the critical value that you will establish for this hypothesis testing will also be positive. Okay, so that's it. Okay, for the two-tail test, the left-hand side critical value formula is chi-square 1 minus alpha divided by 2 nu. Okay, nu here is n minus 1, eh? And then the right-hand side critical value for the two-tail test is chi-square alpha divided by 2 nu. Okay, for the right-tail test, so yeah, your rejection region is on the right-hand side. The critical value formula is chi-square alpha nu. Okay, and for the left-tail test, the rejection region is on the left-hand side. The critical value formula is chi-square 1 minus alpha nu. Macam tu. Okay, so this one is 1 minus alpha divided by 2. This one is 1 minus alpha. And remember again, okay, I really need to highlight this. Both left side, okay, for the two-tail test and left-tail test, both of these will remain positive, which is not the same as the Z and T distribution ataupun the Z and T critical value that we had been using from chapter 3.2 up until chapter 3.5. Okay, so this is a bit different. Please remember that. Okay, I think we are ready to go to the example. Listed are waiting times of customers at a bank. So there are 1, 2, 3, 4, 5, 6, which means that they recorded the waiting times of 6 customers maybe. So this is the data that they get. The management will open more teller windows if the standard deviation of waiting times is at least 0.9 minutes. Is there enough evidence to open more teller windows? Okay, so which means here, this is our claim. Okay, we need to determine, we need to decide whether to open more teller windows or whether not to open more teller windows. So if you're going to claim to open more teller windows, that means you claim that you are sure that the standard deviation is at least 0.9 minutes. So we need to test this, because if it's true that the standard deviation is at least 0.9 minutes, that means we need to open more teller windows. So this is our claim class, if which is to say that the standard deviation is at least 0.9 minutes. Okay, so which means the variance variance Okay, sigma square is greater than or equal to 0.9 square. So standard deviation you change to variance. So the given standard deviation needs to be a square in this hypothesis statement, because please remember class, for this hypothesis testing, you need to remain your parameter as variance. So if the question wants you to test for standard deviation, then you change it to become variance. You can, because standard deviation and variance is actually the same thing, but because of chi-square is meant for variance, that's why the parameter for your hypothesis testing should be variance instead of standard deviation. So yeah, even though the question gives you standard deviation, just change it to variance, and please remember to also square the hypothesized standard deviation given. Okay, so the hypothesized value here is 0.9 minutes. Okay, so you also need to square it, because what they give you here is standard deviation. To make it into variance, you just need to square. Alright class, so this is your claim class. This is your claim in which the hypothesized variance here is 0.9 square. Okay, so that gives you the first step, okay, which is in this case, because the expression used has equal sign, okay, so that means this belongs to the H naught, the null hypothesis. Okay, and then your H1 is less than lah. Okay, this is the pair for greater than or equal is less than. Alright, so this is your first step class. Sigma square greater than or equal to 0.9 square, sigma square less than 0.9 square. Next, you should calculate the test statistics value. There's only one formula, so you need to get the sample variance from this data. Use the statistical function in your calculator, okay? And then substitute all the values accordingly. This is the hypothesized variance, which is this one, 0.9. And you will get you will get 1.1520. So that is your test statistics value. Please remember that for this subtopic, your test statistic value should always be a positive number, okay? Okay, after that, you will want to establish your rejection regions and critical value, kan? So this is a left tail test. Okay, if you look at these two expressions, so this indicates that it is a left tail test. So you will have one rejection region on the left hand side, and the formula is chi-square 1 minus alpha nu. So apa alpha kat sini? 0.01. Okay, which means, so here you need to find chi-square 1 minus 0.015. Apa tu? Chi-square 1 minus 0.01 is apa tu? 0.99 kan? So the critical value here is chi-square 0.995. Alright, so if you look at your formula book, you should be able to find this value lah. 0.5543. So this is the critical value on the left hand side for this left tail test. Okay, critical value 0.5543. Test statistic value is 1.1520. So macam mana tu? 1.15 should be on the left hand side of the critical value kan, because it is bigger. So your chi-square test, your test statistics falls in the acceptance region. The decision should be we don't reject H null. Okay, we don't reject H null. Next, conclusion. So recall what are the hypothesis statements. So the decision is to not reject H null, which means your H null is true. This is the statement that is being supported. So you need to reject H1. So let's take a look at what happened to the claim. Okay, the claim here saying that if your standard deviation is greater than or equal to, apa tadi? If the standard deviation is at least 0.9 kan, they will open more teller windows. And from the decision here, we can see that this statement, this statement is being supported. Okay, they don't reject this statement, which means your claim also they don't reject lah, which means your claim is being supported. Kan? So at alpha 0.01, there is insufficient evidence to reject the claim. Therefore, there is enough evidence to open more teller windows. You can also say that at alpha 0.01, there is enough evidence to support the claim. Okay, we do support the claim because the claim is at H naught. And in the decision, we don't reject H naught, which means we also don't reject the claim. Okay? Then class, that is it for this subtopic. Do try on any of these exercises, and please make sure to watch my next video. Thank you.